Alright, now we'll look at slopes again, tabular. But now let's look at a more likely case in real life. We'll just go with an x and a y, and we'll ask for the slope as the change in y with respect to x, the rate of change of y with respect to x. And but now let's do something like, suppose that's 1 and 2, and then 3 and maybe 5. And then let's go here to 6 maybe, and let's go 8, something like that. Now we'll just do it with a few points here. But now notice if I take different combinations. So one combination, I could take the first two there. That would be 5 minus 2 over 3 minus 1. That would be 3/2. I could take the last two. That would be 8 minus 5 over 6 minus 3. Oh, that's 3 over 3. That's just 1. That's not 3/2. Oops, equals. And now let's take the first and the last. So my slope would be, in that case, 8 minus 2 over 6 minus 1. And that would be 6 over 5, or 6/5. And so we get 3 different answers, and that's all the possibilities we could have. So which one do we pick? Well, there are various ways one could go about it. 6/5 here is the middle of all those numbers. Maybe that's an answer we could pick. That would be one way to do it. The way I'm going to have you do it in the homework is, the getting ready for quizzes and that sort of thing, is really in the case where it's just this general idea of slope. What we'll do is we'll take this one and then that pair, and we'll take the average of those. And if we had more, so suppose now I had a 7 and this was a 10, then I'd just keep going and I would take that one. So we want that slope. We want the 8 and 5, 6, 3, so 3, 5, 6, 8. So we want that slope. And I'll go ahead and do the 10 and 7 as well. So if I do m equals 10 minus 8 over, I'm not sure how I did that. Okay. You are free to make fun of me for not being very good with this thing, but so we get 2 over 1. So we get 2 for that one, and we'll use that. And so what we want to do is take those 3 numbers, so 3/2, 1, and 2, and find their average. So we'll get an average slope. Typically in math, when you want an average, you put a line over something like x bar, we tend to say. So the average slope, we have 3/2 plus 1 plus 2, all divided by 3, because there are 3 items there. And so that's 3, that's 1.5, so that's 4.5. You might use a calculator and get 4.5 divided by 3, and if you put that into a calculator, you get 1.5, or actually the 1.5. So that's nice, a pretty nice number. And we would report that slope. Now there are, there are other methods, and actually statisticians, what they would do is use what I'll say is a more elaborate method of least squares. We won't use that because we would have a hard time really understanding what it was doing, but it would give us a number not way different than 1.5. Okay, and this is just a way to kind of look at the data and get an answer that way. Now, in the case of the graphical that we started with, we then went to tabular and used that formula, y2 minus y1 over x1 minus x2. Well, similarly, we can switch, instead of switching from graphical to tabular, we could switch from tabular to graphical. And so if we take these values, and this will be a very rough sketch here, but if I take my x's and my y's and I try to put some sort of scale on here, so this is 2, 4, 6, 8, 10, and I do the same thing this way, 2, 4, 6, 8, then I could plot those 4 values. I have 1, 2, so there's 1 and 2, so I've got that point there, and then 3, 5, 3 and 5 would be about right there, and then hopefully you're not getting seasick when I do this, 6 and 8. So here's 6 and 8 is there, and then 7 and 10 is about there. So there are values, and they're pretty much in a straight line, but not exactly a straight line. And so what you could do then is you could just draw your own straight line. You know, you put these on graph paper, you do something like that. And as I look at that, now notice it goes right through that point 4,6. Now, nothing else looks real good, but oh, maybe the way I drew it, it either went through the point 710 or maybe it went through the point 12. This is a pretty rough sketch, so let's just pretend that it actually did go through the point 4,6 here and 710. Well, now graphically speaking, what I can do is I can, once I've drawn that line, I can count, and I count this way, that's 3, and that's 4, and so graphically I would get m is 4/3, and so we've got the tabular method, but we can switch to, or tabular method in language, but we can switch to the graphical language by putting the points on a graph and then just drawing a line and using our graphical method to come up with a slope. We got 4/3, which is 1.33, and it repeats. Well, that's pretty close to our 1.5. I mean, so we got the pretty much the same answer both ways. Close enough because, again, like I say, the real answer, so to speak, is using linear least squares as statisticians would. Well, we don't need to do that. We just want to get the idea of, hey, if I have some points, whether they're represented graphically or tabularly, I should be able to estimate about what the rate of change of y with respect to x is. And, that's a nice thing to know, because what that says, if I read a rate of change like 4/3, it says, hey, every time x increases by 3, y increases by 4. And so again, kind of with the tabular idea, if I start out with x and y, and say x was 1 and y was 2, well, then that slope, 4/3, says every time x increases by 3, so I put that up by 4, up to 4, y increases by 4, so that's a 6. And every time x increases by 3, make that a 7, y increases by 4, that's a 10, 10, 14, and I could go on and on. I could go backwards with it. If I take away 3 from 1, I get a -2. And if I take away 4 from y being 2 there, I also get a -2. And so I can start filling things in just by using that slope ratio there that I'm given. Okay, so that's a more complex view of data and slopes, in that you may get data either tabularly or graphically that don't quite line up. They look like they're pretty much a straight line, but they aren't exactly a straight line. Well, we can either attack that by doing what we did up here, finding some slopes, taking their average, like that, or we can come down here and we could draw it and use our graphical method of counting on the graph to get the slope. But either way, we can get the slope. We got slightly different answers. That's okay, but notice they're pretty close, 1.5, 1.33. Either one's going to work fairly well to give us an idea of what the slope is. Okay, so that's it for the tabular method.